Hi and welcome to 6.4, the Apply the Math example. Right, so this is 6.4. Okay, so this one will be a long one, so get ready. Alright, so this question here. So it says 3 teams are traveling to a basketball tournament in cars and minivans. Each team has no more than 2 coaches and 14 players. Each car can take 4 team members. Each minivan can take 6 team members, and no more than 4 minivans and 12 cars are available. The school wants to know the combination of cars and minivans that will require the minimum number of vehicles. I'm going to create a model to represent this situation. Okay, so the first thing we want to do is to identify our variables and our domain and range. Okay, so in here, what we're looking at is the combination of cars and minivans that will require the minimum number of vehicles. So those are our variables. Our variables will be, we can have C will be our number of cars, and we can have M to be our number of minivans. So that's what this question is really looking at, are the numbers of the cars and the numbers of the minivans. Okay, and what number set do these belong to? This is what's also called the restriction. So what's the restriction or the number set here? Well, the number of cars can't be like a half a car or 1.2 cars, right? So C has to be an element of the whole number set. And minivans, same thing, whole number set. Okay, so the next step in the process then will be to determine the constraints. So the constraints, as it says here, is a limiting condition of the optimization problem being modeled, represented by a linear inequality. So that's our constraint, it's the linear inequality. So if we look at the information in the problem, we're looking at, okay, what do we know about these variables? So the number of cars and the number of minivans. How are they limited? So if we look at the information, right, we have that no more than 4 minivans are available. So that tells us that M is less than or equal to 4. It could be 4, could be 3, could be 2, could be 1, could be 0. Can't be 5. We can't have 5 minivans. Okay, and the number of cars says no more than 4 minivans and 12 cars, so that means there's also less than or equal to 12 cars. So that C is less than or equal to 12. And then what else do we know? Okay, well, it tells us this other information that each team has no more than 2 coaches and 14 players. So that tells us each team has up to 16 people on the team. So if there's 16 people on each team, remember the question says there's 3 teams, right? So 2 coaches, 14 players, 16 per team, 3 teams, that means there's 48 people in total. Okay, and it also tells us, so we've got 48 people. Doesn't say there's 48 for sure, but it's up to 48. Okay, 48 is the highest number of people that might possibly be going. Okay, then it says each car can take 4, each minivan can take 6. So we take that and turn it into a linear inequality, where we have 4 times the number of cars we're taking. So basically, if we had 1 car, that'd be 4 people. If we had 2 cars, they'd fit 8 people, and so forth. Plus 6 times the number of minivans we're taking. So again, if we had 3 minivans, that would be 6 times 3, we'd have 18 people. And then that number there is going to be less than or equal to 48. Remember, we've got 48 people in total, up to 48 people in total, sorry. We have up to 48 people in total, so the number of people in the cars plus the number of people in the minivans has to be less than or equal to 48. We don't need to have room for 50 people, we don't need to have room for 100 people, we need to have room for less than or equal to 48 people. So those 3 things are our constraints. Okay, third part is our objective function. So what is an objective function? So it says in an optimization problem, which is what we're doing here, the equation that represents the relationship between the 2 variables in the system of linear inequalities and the quantity to be optimized. Okay, so it's an equation. An equation means there's an equal sign. Okay, so this isn't a less than or a greater than, this is an equal to something. Okay, and it says it's the relationship between the two variables in the system, so that's M and C, and the quantity to be optimized. Well, what are we trying to optimize here? Well, let's go back to the problem. It says we're trying to figure out the combination of cars and minivans that will require the minimum number of vehicles. There's our key. Minimum number of vehicles. That's what we're trying to optimize. So what we need to do is introduce a third variable, which could be V, which represents our number of vehicles. And then from there, our objective function is actually pretty simple. Our objective function is the number of vehicles is equal to, well, the number of minivans plus the number of cars. So it's just V equals M plus C. Okay, so the objective function always has three variables in it. It's going to relate our two other variables that we were dealing with to a third variable, which is the thing we're trying to optimize, which in this case is the number of vehicles. Okay, to see the fourth part of this question, please watch the next video.